Okay, for our islands, we will bold it. There. And then we will setting up time property. We will turn the Kachina track on. Oopsies. Wow. Look. So this is really nice. So, and we will zoom to layer, and this we will do symbology. And in the symbology plan, we will do graduated colors. And field is pressure. And we will do classes as 5 with a color scheme of yellow to red. Yellow to red. There. And then more symbols, format all symbols. Okay, and click property and change line width. So we will change the line width into 5th. Okay, number 5. And then we will click apply. Doesn't like the typing, so if not, it doesn't show up. And then we will right click on Kachina property time. Right click on here. Okay. Property, and then we will go to time. Okay. We have time, and each feature has a single time field. Okay, and time field is time 2. There. So then we will format it, and we will click OK. That should be fine. Okay, we can set the time property of the temporal data. Using the information stored in the data source, we can store this temporal information in attribute fields for future classes or mosaic data sets. And here in the Kachina track datasets, the time field is time 2, which displayed data as the year, month, day, hour. And the time slider appears at the top of the map, and then we will click play arrow. So we go back to time and we will play. This is really interesting. Wow. Okay, when the time is enabled for any of the layer of the map, the time tab appears on the top of the display, provide opportunity to configure the behavior of the time slider and its controls. Okay, and then because there are 18 days of data, set the number of steps to 18. So, number of steps, we will do 18. Okay, and it's August 15th. Okay, start August 15th. 2000. All right, and span, it will be 14.399 days. And it will be August 30th. Okay, yeah, around 4 o'clock. That's fine. Number of steps 18. And then we could be a little slower, and then we can just play. Alright, so this is really nice. And click play on here and we will run this animation. We describe the geographic area, specific names, land formats, and places. And write an analysis description, the variables that their interpretations. For example, how does hurricane wind speed varies based on location over land or water. Wow, look at here. So, or how does hurricane pressure vary with the depth of water? So refers to the map and as the composed of analysis. So deliverable. So let's see. So we have this. Going to save it. Alright, and we are ready to begin quantitative analysis of the problem by identifying the types and amount of land cover most affected by storm surge. For this part, the analysis must be make a new map. Next, we will duplicate and rename a map, flooded land. So to do that, we will click Maps to show current map, and click Map and rename the map Hurricane Katrina. So I'm gonna rename this Hurricane Katrina. And we will create map showing direct traffic patterns and drive time. We want a new map to contain all the layers and symbolizing showing the Katrina, Hurricane Katrina map. And we will right click on copy Hurricane Katrina. Okay, so let's see. I can just do Control C. Oh no. Control C. Control V. They don't have like a copy. So, oh, right here. So, right click on it, copy, and then paste. Control V. There. Okay, then I will call it flooded land. So if you copy and paste that, you have to do it in the Arc catalog. So which is right here. And after renaming the map, we double click to see how we have two maps, and we can toggle them, zoom counties if we need it, and turn some layer off. So I'm gonna drag it here. Oh, it doesn't go, so we're gonna go to map. So I'm gonna insert a new map that, oh, I cannot just do insert map. Can I just drag this here? Okay. There. So go to flooded map, Katrina map. You double click there. You double click on it, and I'm gonna turn Katrina check off, and then reverse places, reverse, and then water, and we can zoom into islands. Okay. Zoom out a little bit. So we will change the elevation units. So in the contents pane, we will drag the elevation on top everything. Elevation. Okay, now we have elevation. Above counties if needed. Yep, we did. Before we go further, okay. Before we go further with the analysis, we must know the unit of elevation. So on elevation, right click on it, and then we will go to property, and then go to elevation. So elevation feature, notice that the unit elevation is in meters, which I love. The storm surge was was 15 feet. In converted a elevation from meters to feet, we will need to multiply each elevation value in elevation by 3.28. 1 meter equals 3.28 feet. So on collapse elevation, and we notice the lowest and highest elevation is in meters. So right here. And then we will go to analysis. Okay, go to analysis and we will go to time. So analysis, we will go to tools and we will type time. So time, there are a lot. Since we are dealing with raster data, so each cell of raster will be multiplied by the conversion factor to change the elevation units from meters to feet. So this tool multiplies the values on cell-by-cell sizes. So we will click time, and there will be 3D analysis tool, and open the menu and use the following parameter. Input raster, it will be elevation. Okay, and input raster constant value, and there will be value 2, so it will be 3.28. That's the conversion. And output, okay, output raster that I'm gonna put in the geodatabase, which will be elevation and underscore foot. Okay, and then we will run the tool. Perfect. And close the geoprocessing pane when it's done. So as we examine the data and the result of the analysis, we can see that the lowest and highest elevations are now given in feet. The elevation is also now clipped to the counties layer. This clip is the result of setting the mask in environments to be counties. When we click elevation feet, the raster layer on the appearance tab becomes available. Here is where we will find all the essential raster functionality to adjust the display and appearance on the raster. So, and appearance is right here. And on the raster tab, we will click rendering and then choose symbology. So rendering. It's right here, rendering and symbology. Symbology. Okay, and once we have okay, symbology. Okay. Symbology. Okay. Oopsies. Okay. Yeah, I did symbology. Appearance. So we're on appearance and we click rendering and symbology. So you can see the interface, they changes a lot. It's totally different right now. Okay. Then on the raster layer tab, and click the rendering and choose symbology. Under classifying, so classifying, following the parameter symbology, we will do classify. Cool. Wow, it's cool. And then use the following parameter. So symbology, we say classify. Yep. Method. Yep. Natural breaks. So we will do natural breaks. Jenkins classes 5. Color scheme appropriate for elevation feet. So we will do elevation. Elevation scheme we will do is, let's see, which one looks better. Okay. Not this one. Maybe the second one, elevation 2. Alright, yeah, this one looks a lot better. And then we have everything like here, and now we got the time and everything, and so, and I'm gonna close this out. Wow, this time is really cool. We can play the time and see what's going on. Nothing changes yet.